Hey folks, Quilly here, and welcome to another episode of our mostly civilized hex engine for Unity. In this episode, we are going to work almost entirely, I think, on the unit.cs script file here in preparation for some pathfinding stuff. We're going to take sort of a bottom-up approach to getting ready to do some pathfinding, in that we're going to create a couple of functions that we know we need to have exist in the unit class over here in preparation for our pathfinding. Although before that, what we're going to do is we're going to start with the code that allows us to pass a path to a unit, a path that this unit will follow in some way going forward. So very simply, what we're going to have is we're going to have, okay, we've got generic added in there. We're going to have a list, actually technically this is going to be a queue actually, of hexes, which is going to be like our hex queue. Really, it's a hex path, I suppose. We in our unit code aren't literally going to check and verify that it's a legitimate path. It's going to act just as a queue of hexes that we are going to walk through one at the time. But I think we could probably do something like call it something like hex path. I think that's pretty legitimate. And the whole thing with the queue type is the queue is a data structure that's organized so that things get added to the back of it and then get popped out of the front. And it's very well organized for quickly doing that kind of thing. Logically, it's very much what we are hoping to do. Although we could also use like an array with like an index that we push along there and then clear out the array later on. But I think that if this is logically what the kind of data we're trying to represent, I think it makes sense that we use this. We can always change the actual data structure behind the scenes later on if we decide we need something that's optimized in some other way for some other reason. But for now, this is going to be perfectly okay. So we're going to have this sort of internal hex path, and obviously we're going to need some sort of way to set it. So probably something like public void set hex path. And what this is going to expect, I mean, we could expect a queue here, but really to make it like accessible from any kind of thing. For example, there's a great possibility that whatever's going to pass it here is going to be using a list or an array or this or that. I think we're just going to accept an array. And again, we might end up tweaking this later on. It's kind of weird to change from one data type to another, but basically we need some sort of array list queue thing that describes our hex path over here. And all we're going to do is we're going to set our actual hex path, or rather I should say this.hexpath, to be equal to a new queue, and you can pass anything that's enumerable in there, which a array should count for that. I don't believe I'm lying to you in that particular respect. If we hit F8 to build, yeah, no compilation errors over here. So this is going to set up a new queue in here, and we're going to ignore our old one. And then on do turn, instead of doing this, moving one tile to the right, what we're going to do is grab the first hex from our queue, if we have one, actually. So I guess we're going to do something, so do queue move, okay? We're going to do something like if hex path is equal to null, or hex path dot count is equal to 0, then we don't have any moves queued up whatsoever, so we can just return right away. That's perfectly okay. I don't think there's any reason to raise an error. I think this is something we're often going to cycle through all of our units in our game, tell all our units in the game to move, and some will simply have no moves queued up, and so they can just return just fine. So what we're going to change here is we're still going to save our old hex, but our new hex, instead of grabbing the tile to our right automatically, which is what we're doing for our debugging, instead this is going to be from our hex path dot dq. So this will remove the oldest entry in the queue. The queue type is a first in, first out type queue. So it's not a stack. You add things to the tail of the queue and you remove things from the head of the queue over here. So we've got a new hex from there. Great. And then all we have to do is move to the new hex, like that. Nothing else for us to do. In fact, we don't even have to save the old hex in this particular code, because we take care of the old hex stuff over here for flagging unit moved. And there we go. So that's it. So now we have the ability to set a hex path and then move along it whenever do turn gets called. Do turn gets called automatically whenever we hit the space bar right now. We'll need, obviously there'll be some other mechanism for doing that later on, but right now this is in our maps update. It checks to see if we hit the space bar, and if so, it calls do turn on all of our units. And if that's got anything in the queue, it'll do that. I mean, we don't have anything that sets a path right now, although we could very easily do it, test it out, but we can test this later. That's perfectly fine. Now, the next part is we're going to need ultimately 2 helper functions here for our pathfinding one. The first one is going to be pretty obvious, and it's going to be something that we're going to want for lots of things. We'll clearly make it a public, that's fine. And I think, and this is a little, well, this is going to be an integer. This function is going to be something like movement cost to enter hex, or something like that. Okay? And this is going to take a hex. We might rename this. But the idea is we want to know how much would it cost this unit to enter a hex. Now, we could have this function be part of the hex itself, for example, right? We could have the hex have a function called movement cost to enter, and you pass it a unit. The reason that you need both, at some point you need both the hex and the unit, is because different units will have different types of movement rules, right? For example, if it's a flying unit, that doesn't care if we're talking about a forest or a hill. If it's a boat, then it can't enter land. If it's a land unit, then maybe we have to do some weird embark maneuvers. If we're on a road, if there's a forest, if there's a hill, if there's a mountain, so there's different things that will ignore or treat different tiles differently. Units might have different types of traits or promotions. For example, you might have a scout that ignores difficult terrain. You might have a warrior that's been upgraded so that he can ignore forests, that sort of thing. And so the movement cost is really going to be, the movement cost to enter a hex is really going to depend on what unit we're talking about. And it feels like, because the unit is the thing doing the activity, to me it feels like, therefore, this function should be part of the unit itself. Now, currently, we don't have any real hex types, actually, at all, right? We keep track of elevation and moisture, and we use that to set the visual for the hex, but at no point are we actually setting up the hex type yet. For example, the hex, as far as I know, I don't think we've done this, the hex doesn't know if it's flat, a hill, or a mountain. It doesn't know if it's supposed to be a plain, a grassland, etc. And clearly that's going to have to be something that happens. That's going to be at some point in the hex map data over here. Right now, like here's all our code, one big messy function. Well, I mean, it's not messy, it's not particularly commented, and it's trying to do a lot, which I don't tend to like. I like my functions to do fewer but more focused things. So here we're setting the material, and we're setting the mesh of our visual tiles to represent the type of the content. I just realized this might be a little bit slow because I am currently rendering some videos. My bad. Words. Yes. But we don't actually set the type, and that's okay. We're gonna do that later. But I mean, so they'll be like, to do, need some kind of property to track hex type, plains, grasslands, etc. To do, need property to track hex details. So forest, mine, farm, etc. Right? We don't have anything like that right now, and that's okay. So right now, the movement cost to enter a hex, we will just assume it costs 1 movement to enter the hex, right? I suppose what we could do is we could still, yeah, you know what? We're gonna set something up, and it could be a property, or it could be a function. I think it's gonna be a function if I can ever. I slid the keyboard slightly, so everything's slightly offset. So this is going to be something like movement cost to enter. Okay? And that's going to be fine. And what we're going to do is to do factor in terrain type and what I call it, and features. All right, but for now, we're just going to return 1. All tiles will cost 1 to enter for now, and that's okay. And then over here, what we're going to do, well, so I mean, we've got the base movement type, but yeah, again, that's not going to be everything, because what we're going to have to do is use this base value. I don't know. I guess we'll call that base movement cost. There you go. Base movement cost is going to be this. So this is going to return hex.base movement cost. This is in our unit, but it's going to be something like to do override base movement cost based on our movement mode plus tile type. And this might be something that we interact with the tile type a little bit more. You know, there might be things we can ask. We might be able to pass a filter to this. Like we might offset some of the code logic actually to here, for example, to say my base type is walking plus forest walker, right? And so then somewhere along the way you figure that stuff out. It might be part of the unit code. It might be part of this. Either way, it's going to be fine. Okay. So that's going to be one thing, and right now it's going to always, this is always going to be returning 1 because this always returns 1, and that's okay. But that's not our true pathfinding cost, right? This would be fine now that we've got some sort of function to explain the cost to enter a hex. You could go and start on a pathfinding system. But the funny thing about civilization type games is this is not the true movement or pathfinding cost, because we don't want to find the route with the lowest total movement cost. Instead, we want to find the route that takes the least number of turns. And these are not always the same thing. And in fact, what we're going to want is another function that's something like aggregate. I know it's going to sound stupid. It's probably a better way to phrase it, but we'll think about that. Aggregate turns to enter tile. Okay? And we're going to want, we're going to need or enter hex, I guess, to be consistent. A hex tile. We're going to want a hex. This is the one we're going into. But then we also need something like turns to date. And the reason you have is this. Let's open up some comments so that we can write an example. The issue at hand is that if you are trying to enter a tile with a movement cost greater than your current remaining movement points, this will either result in a faster than, or I should say something like cheaper than expected turn cost, Civ 5, or a more expensive than expected turn cost, Civ 6. What do I mean by this? Well, think about this. Let's say you've got a unit that has 2 movement, okay? Normally, that's their maximum movement, is 2. But they've just moved 1 tile. They just moved from a grassland to a grassland, for example. That cost 1 movement. So now they have 1 movement left. Now your unit wants to enter a forest. A forest has a movement cost of 2. It costs you 2 movement to enter a forest. In a Civ 5, your unit with 1 point of movement left can still enter the forest. Obviously, it will leave him with 0 movement remaining. In Civ 6, you can't. It will stall your movement, so you will have 1 movement point that you have not spent. You're going to end your turn there with 1 movement point left, and you're not going to do anything with it. And your next turn, you will enter the forest. In Civ 6, if you're at full movement, you can always enter a tile regardless. If there was a tile that cost you, I mean, it's not possible, but hypothetically in Civ 6, if the cost to enter a tile was 10, and you were a unit that had a maximum movement of 2, well, you could always enter that tile anyway. It's just that you could only do it if you were at your maximum number. So if you're at 2 of 2, then you can enter the next tile. So it means that in Civ 5, you actually end up with free moves sometimes. There's optimal sort of movements where you can move here, use half your move, and then enter a difficult tile, which would have otherwise cost you your entire move. But in Civ 6, you end up going slightly slower because a lot of times you will not be able to spend all your movement points just because you want to enter more difficult terrain. So that's why we need this kind of function, because what you're really asking for the pathfinding system is not how many movement points does it cost to enter this tile, it's how many turns is it going to cost me to enter this tile. And usually the answer will be less than 1 turn, actually, right? So again, if you've got a movement speed of 2 and you're trying to enter, say, a flat grasslands tile, then it will cost you half a turn. right? If you got a movement speed of 4, then it'll cost you a quarter of a turn to enter that tile. So a lot of times, the fact of the matter is it's costing you less than a turn. But sometimes it will cost you more. So for example, if in that example where you have one of 2 movement remaining and you're trying to enter a hill or a forest tile, then it's going to cost you a turn and a half, right? It's going to cost you your the half turn you have left plus your whole turn next turn. And that's kind of an interesting thing to consider. So that's why our pathfinding system only cares how many turns does it take us to get there. And if the move is going to take, if ultimately at the move it's going to take less than your full turn, or, maybe it'll take a fractional amount. It's going to take you 5 1/4 turns to get there, i.e. it'll take 5 full turns, and then it'll use 1 of your 4 movements on your final turn, so you'll get there with 3 movement left over. That's, that's the shortest route. That's what you're looking for. So that's why we need to know how many turns we've used so far. And then the question is, when you return at the end, do we return the number of turns this move is going to take? I say no. This is an aggregate function, so return the total movement cost, or the total turn cost of turns to date plus turns for this move. Okay, so you might call this function, and the turns to date so far, like it's a long move, so you've used up 4.33333 turns so far, and we're going to return that this next move is going to bring your total cost up to 5 turns to enter this tile at that point as an aggregate. I think that's a fair way to go. So our unit has a movement rating, and it has a movement remaining rating. So we're going to go ahead and make use of that and say something like, so first of all, the big question is, float, something like immediate, or we'll call it base. Base turns to enter hex, okay? So this is just going to be the movement cost to enter hex. All right, this is the total number of movement costs to enter the hex, divided by, I guess, our total movement amount. All right, so is that the way we want it? Sure, we'll do that. And then we'll also have something like turns remaining, or yeah, turns remaining, which is our movement remaining divided by movement. So now everything is in terms of movement. We don't have, or sorry, in terms of turns. That's kind of an awkward thing to say. We don't care about movement points anymore. We just say, so again, if the example, if we've got base movement of 2, so entering forest is 1 turn. Example, if we are at 1 of 2 move, then we have 0.5 turns left. Something like that. So we've got something fair to confirm. Next, we need to look at our turns to date. So we're going to split this into 2 subsets here, because we want to know the difference between the sort of the whole part. So turns to date whole. So mathf dot turns to date. Oops, sorry. Mathf dot floor turns to date. Okay. So if turns to date comes at us and it's a 4.33, example, 4.33 becomes 4, and then turns to date fraction is equal to turns to date minus turns to date whole. I think we're gonna need both of these. So example, 4.33 becomes 0.33. Because we're going to factor that in with the base turns to enter the hex. Now, there's a possibility. I mean, everything's going to be fine with our units probably that move at, have a movement speed of 2. I'm a little concerned about units having a movement speed of 3, that we're going to get a lot of these like, 3, 3, 3, 3, 3 repeating. I mean, they don't repeat infinitely because there's a cap to that, and then you get floating point precision errors and whatever. I'm not going to do anything about it right now, but I'm going to put a little check here. If turns to date fraction is less than, say, 0.01, or turns to date fraction is greater than 0.99, for example, then we'll just put in a little like notice for us later on. It looks like we've got floating point drift. Most likely what we're going to want to do is like round or something like that. Round things? Well, for example, so if turns to date fraction is really like, you know, just a tiny little bit that's slightly above 0, then we're probably just going to set it to 0. If it's greater than 0.99, that what we'll probably want to do is increase turns to date whole by 1 and then fix that to 0. You know what? We'll go and put in the fix. I don't know if this is like what we're ultimately going to want to do, or we might want to represent things not with floating point numbers. We might want to come up with some sort of like false decimal system or something like that. We'll worry about it some other time. We could do, as long as like, you know, unit speed never exceeds certain numbers. I don't know. We'll come up with something. But so like something like, so again, if it's less than this amount, then let's force it to be 0. Mostly this is, I'm concerned in the example where we've got 1/3 movements. Then you can easily see what can happen is you can end up with 0.33 plus 0.33 plus 0.33, which equals 0.99, which is not the same as 1 in this numeric system. Obviously, in real life, everyone knows, God, I'm going to start a giant internet argument, but 0.33333 repeating multiplied by 3 is actually and truly 1, not infinitesimally close to 1. And listen, that has nothing to do with programming. This has to do with real numbers. But programming doesn't get to play with real numbers. They only get to work with floating point approximations, which is why we get to this bullshit. So we've got that, and if turns to date fraction is greater than this, oh, I should put in a little f over here. So if it's greater than that, then we should actually assume that, well, turns to date whole is actually supposed to be 1 higher than what it actually is. There we go. So something like that. This may or may not be the sort of thing we want to do, but I can foresee it happening, which is just why I'm like, maybe we should at least check to see if it happens so that we're aware of it and maybe make an adjustment later. Anywho, so what we want to do now is we want to see, so turns to date, so base turns to enter hex. So the big thing is something like turns used after this move, which is going to be something like turns remaining plus it's turns to date fraction plus base turns to enter hex, right? So in our example, this would be 0.33 plus plus 1 to enter the forest. Okay, in our example, oops, we're entering a forest which has a cost of what's actually 2. Oh, it's 1 turn. Given our current weight, it takes a full turn to enter the forest, and we have 1/3 of a turn left. Okay, so then the big question is, if turns used after this move is greater than 1, we have hit the situation where we don't actually have enough movement to complete this move. What do we do? So what we're going to do, and this is like, we're going to have this somewhere else for now, okay? But I'm going to have a constant Boolean set up here that is just set to do movement rules like civ 6. We'll set it to false or whatever. Okay, I don't want this to be here. This is for testing. This is like Here, I'm going to get rid of to do. I'll put a to do here. To do. This should probably be moved to some kind of central, oh my god, option/config file. Okay, but we don't have that kind of support right now, so we're just going to go ahead and hard code in a const. It'll be moved later on. That's okay. So this determines are the movement rules like Civ 6. So if movement rules are like Civ 6, then we aren't allowed to enter the tile this move. That means we have to ... sit idle for the remainder of this turn. So what are we going to do? So what we're going to do is we're going to set turns to date whole. We're going to add 1. Okay. And the turns to date fraction, we're going to set to 0. So in this case, when we came in having used 4.33 turns so far. But after this, we're going to have sat for a full 5 turns. Because we used that extra 2/3 of a turn we did there just sitting at the edge of the forest doing nothing. Then what we're going to do is add in the cost of entering the difficult terrain. Well, not exactly. Because it's possible here. It's possible here for us to have entered with turns to date fraction is equal to 0. We got to check this. So if turns to date fraction is equal to 0, this means we have full movement. Even though this isn't enough to enter the tile. So this is what happens in this situation. We have full movement, but this isn't enough to enter the tile. Example. We have a max move of 2, but the tile costs 3 to enter. Okay? So that's what happens. If turns to date fraction is equal to 0, then that means we came in here. We haven't spent any of our turn. We've come in, this would be an example where we came in here with turns to date being exactly equal to 6. We've spent 6 turns getting here, and clearly this would be a fresh turn with us having used 0 of our following turn. Their fraction is set to 0, which means no matter what, we can enter the next tile, and that's fine. Else, we are not on a fresh turn. Therefore, we need to sit idle for the remaining of this turn. There we go. So we actually don't do anything in this first case. But I do want this like little brace here so that we can have comments. We are good to go. Although we could have an option where you're literally not allowed to enter a tile if the movement cost is greater than your max movement. But I think that would be a little bit foolish, wouldn't you? I think so. So now, having done this, we are now on a fresh turn. Either way, so now we know for a fact that we are starting the move into difficult terrain on a fresh turn. Either we already were on a fresh turn, or we've indicated that we're going to have to sit idle for a whole turn. Note that we're going to have to implement this in the actual movement rules as well, right? So there's a bit of a duplication there. But what we'll probably do is we're going to take some of this code, factor it out to a function that will then be used for the actual movement. Because this is going to be something used by the by the movement planning code, not the actual movement code. Although there's going to be a lot of crossover, and we're going to have to make sure that's the case. That way, if you make changes to the movement rules, it also applies to the movement planning rules. Otherwise, bizarre things will happen. So we can set turns used after this move. We can set it to be equal to the base turns to enter hex, right? Because we don't have to calculate in turns to date fraction anymore. So that's okay. Yes. So then the other possibility is else. Civ 5 style movement rules. And every version of Civ has like inverted these various rules here. State that we can always enter a tile even if we don't have enough movement left. There was another one where, was it like Civ 3? I think maybe, where you actually might have taken multiple turns to enter a tile with a very high cost. And that was no fun. We don't want to do that one at all. Okay, so we can always enter a tile even if we don't have enough movement left. That's totally okay. So in that situation, well, we pretty much just say turns used after this move will be equal to 1. Yeah, so yeah, we're not looking at the base cost. We're saying it's going to take you a full turn to use this move. It's going to set it to 1 no matter what. Not a fractional or anything like that. It's not going to be above 1. It's just going to be 1. Like, we don't carry it over to the next turn either. We don't eat some of next turn's movement or anything like that. And then we come down here and we say, so turns used after this move is now some if turns used after the move is greater than 1, just set it to 1. There you go. In the example where we're trying to enter something that has a base cost of 3, because base turns to enter hex could conceivably be a value greater than 1. It could be. Because if movement cost enter 3 is 3 and our movement rate is 2, this could have a value of 1.5, which is fine. All right, turns used after this move. We knew this. I mean, we could set base turns to enter hex. We could force it to be equal to 1 turn no matter what. That's actually not a bad idea. That's actually not a bad idea. Like, we could consider that over here. If base turns to enter hex is greater than 1, then set base turns to enter hex to 1. Even if something costs 3 to enter and we have a max move of 2, you can always enter it using a full turn of movement. So that's the cap, no matter what 1 turn worth. So the other way to think of this is if a tile costs 3 to enter and our max movement is 2, then really the cost to enter for us is going to be 2 movement. That's exactly the same. That way we don't have to do as much worrying over here. So at this point is now some value from 0 to 1. Okay? I mean, it should never be 0 because we probably don't want free moves in the game because I think that's really going to confuse the Pathfinder. But let's assume something like that. Most likely in a Civ type game, it's either going to be 0.5 or 1. Well, yeah, or it could be some other value because this includes the fractional part. This includes the fractional part of moves from previous turns. Right, so if we have a movement speed of 4 and we're trying to enter a force which has a movement cost of 2, but last turn we've already moved 1 tile. So let's say we've moved 1 plains tile, so that costs us 1 move or a quarter of a turn. So we came into this with 0.75 turns remaining. Our turns remaining was 0.75. And let's say this is the start of a move, so we haven't really done anything yet. So moving into the forest, so these would all be 0 values. So this would be a 0, this would be a 0. Turns used after this move would be, because the base turns to enter the hex would be a cost of 2. Our total movement is 4, so it would take 0.5 turns to enter the hex. With our, I guess our turns to date fraction would actually 0.25. Yeah, this would be 0.25, and our turns remaining would be 0.75, which means that turns used after this would be the 0.25 plus 0.5. So that's the movement we spent, the turns we spent moving onto a plane, plus the movement we're going to spend trying to enter the forest. So now 0.75 is that, which means here, so turns used after move will be 3/4 of a turn will have been spent after this move, which is correct. And so what we're going to want to do is add this to the turns to date hole, and that's what we're going to return. I guess I'll put the note down here. Return turns to date hole plus turns used after this move. Like that. So in the case of our horseman trying to enter a forest, this would be a 0 plus the 0.75, which means at the point that we enter the forest, we'll have used 3/4 of our moves for that turn, which is correct. Again, this is an aggregate function, and that's what we're trying to return. Or in the case of our other example here, let's work through it here. That we are a warrior with a base movement of 2. We're trying to enter a forest. Somehow we used 1/3 of a move before. Maybe we're moving along a road, right? Let's say a road has a movement cost of 1/3 of a movement. So that's why. So, I mean, this is a queue, right? We've done a queue. We spent 4 turns moving somewhere along the way. And on this turn, on our 5th turn of movement, we spent 1/3 of our movement moving along a road. Okay. Then we're trying to enter into a forest. So turns used after this move would be 1/3 of a turn plus a full turn to enter the forest. So turns used after move would now be equal to 1.33, which means it's greater than 1. And if we are doing Civ 6 style rules, well, first of all, turns to date fraction, is it 0? No, this is 0.33. So we go here instead, which means turn to date hole becomes 5, the fraction becomes 0, and the turns used after this move becomes the base turns to enter the forest, which is 1. So what we end up with is a value of 5, 0, 1. So 5 whole turns and 0 fractions, and a cost of 1. And we return the 5 whole turns to date plus the 1 to enter the forest. So it's going to cost you, to get into this forest at this point, it's going to cost you a total of 6 turns. That 5th turn is going to be very boring. The 5th turn is going to be moving 1 tile along a forest, or along a road, and then stopping outside of forest with 2/3 of a turn worth of movement just sitting there wasted. To try to enter this forest. But that's Civ 6 for you. If we look at the Civ 5 set, like, so if this is not true, if we don't work like Civ 6, we're working like Civ 5, instead what we do is we set the turns used after this move. So we're back to the example where our whole turns is 4, our fraction was 1/3, and our base turns to enter the hex is a full 1. So turns used after this move would be 1.33, but instead we say, oh no, after this move, after you enter the forest, it's just, you're going to have used your full movement for the turn, which means that effectively the bit along the road was free, because it should have cost us our whole turn to enter the forest, and it did cost our whole turn to enter the forest, plus move along the road. So the road bit is free, and in the Civ 5 rule set, we're returning the whole part, which is 4, plus the turns used after move, which is 1, for a total of 5. So in the Civ 5 rule set, it would cost us 5 turns to enter that forest. In the Civ 6 rule set, it would cost us 6 turns to enter the forest. Hey, 5 and 6, that worked out really well. I think this math, I mean, there's a lot of explanation, and I mean, you know, you can simplify a lot of this code, I'm sure, but it's, you know, it seems pretty clear. This is a little funny thing to, like, you know, maybe catch things. Again, this mostly has to do with 1/3, because I think if you move along the road, if you make 3 moves along a road, I think that normally this code would return that the total movement used to date would be 0.999999 and stop at some point when you hit the limit of floating point stuff. Plus, there's weird things like in floating point numbers where, because it's representing things binarily, even equations that are clear to do with decimal numbers are not clear to do with computer floating point numbers, and you end up with like, it's like 1 divided by 5 is supposed to be 0.2, but in computer floating point, it's going to be 0.200000001 or something like that. I don't know if 1 over 5 is an example of that, but it might be. So I'm sure we're going to have to do a few of these things, or use a different number type that more cleanly handles decimals, even though the math might be a little bit slower for the processor to deal with. I don't know. We'll figure that out later. But I think this works, and so we still don't have real movement costs because everything just costs 1, which is fine for now. So I think the next thing we're going to do is we'll actually start the A-star pathfinding code using a movement cost of 1 for everything. We'll confirm that it generates a path. I mean, it'll always be a straight line path because there's, you know, it doesn't care about hills and forests. It'll always be a straight line path, but we'll confirm that it actually does move a unit from point A to point B. And then what we'll do is, at that point, introduce our system for hex movement cost, and then we'll run the algorithm again and confirm that it still goes from point A to point B, but it tries to avoid things like hills and forests and things like that, or impassable terrain like mountains, right? Mountains will be impassable to land units, for example, and that should be pretty good. Thanks for watching, folks. See you next time. Hey, I want to say a great big thank you to all the June Patreon supporters and these Mic Check supporters. We've got Yukofin, Eric Sumner, Tiburon, Mighty Mix, Pavel Zdanov, Drazion, Michael McClintock, Aaron Toyson, Craig Mortel, The Not So Evil Engineer, Julien Auger-Lafont, Marius Fieldvold, Speedy Savant, Valiant Cakeveen, Thomas Oberson, Jason Yanity, Stephen Bonnerman, Kale the Quick, and Neil Blakey Milner, and absolutely everyone who watches, shares, favorites, and subscribes to these videos. Thank you so, so much.